Alright, hi everybody, this is our third video. This time we're going to discuss piecewise defined functions. Hopefully I'll do this recording quickly because I'm at the school and the bell keeps ringing and it's driving me crazy. This is like the third time I've had to restart it because of the bell. Alright, let's go ahead and get started. Make sure you have your notes with you. You can fill them out as we go along. This first page you just need to write down the words that I'm going to uncover. And the first thing I'm going to do is erase some of the words that I've covered up. So the first part, you need to know the definition of a piecewise defined function, and it's a function that uses different formulas or rules depending on what values of x are being used, okay? So the notation looks like this. You will be able to I guess when you come into class on Thursday or Friday, you will be able to, I'll show you how to plug in the formulas to graph piecewise functions like this. Alright, so let's go ahead and finish this page. You need to know the intervals used can be open or closed. That refers to our dots. You know, right here we've got a closed dot here and an open dot there. You can have both, okay, or they can be infinite, but they should not overlap, okay. Notice that these are one on top of each other, but notice that if our x value is 2, you are not going to be down here, or you're not going to be on the bottom one. You won't be down here. You will be up here because this one is closed, okay? So even though those two do overlap, you can't be in both places at once. You will always be on the top one. All right, and then graphically, the pieces of the function can be connected, but they do not have to, okay? So this graph up here is one where your pieces are connected. They connect right here. This one, your pieces are disconnected. All right, let's look at the next page. All right, with this one, I've got two examples of formulas that will give you a piecewise function. Let's look at both of them. We can do these without a calculator. If x is -2, then I'm going to have a 2 in the numerator and a -2 in the denominator. That just gives me -1. If x is -1, I get 1 in the numerator, -1 in the denominator, gives me -1. If I have x of 1, I get 1 in the numerator, 1 in the denominator, which equals 1. And then if x is 2, I've got 2 and 2. Now, what happens if your x is 0? You're going to have 0 in the numerator, 0 in the denominator. If you try to do that, you will get an error. So you're going to end up with an asymptote right here. Okay? However, when we are drawing the piecewise functions, we're going to show that the graphs will get close to it. Notice I have an open circle, and then on this side of the graph, I'm going to be at +1, and then on this side of the graph, I'm going to be at -1, and that's what this piecewise function is going to look like. All right, so let's look at the rules. Your y is going to equal either -1 or +1. When is it going to equal those values? Well, if x is less than 0, we're going to get -1. And then if x is greater than 0, we will get +1 here. Okay? These are the rules or the formulas here, and this is when it's going to happen, or the restriction of when it's going to happen. All right, let's look at number 2. The formulas are a little bit more complicated. So when x is -2, we've got -2 plus 1 and then -2. So we've got what? -3. When x is -1, I've got -1 plus 1 minus 1. So I've got -1. And then when x is 0, I've got 0 plus 1 minus 0, so it's just +1 And if x is 1, I've got 1 plus 1 minus 1, and x is 1 again. All right, so it looks like when x is 0, I'm at 1, okay? And I'm going to go ahead and fill that circle in because I do land there. And then on the right side of the graph, I'm always going to be at 1. On the left side of the graph, I'm going to decrease. So when x is -1, I've got -1. When x is -2, I've got -3. So it's going to look like I'm going down like that. My slope, I'm going, let me change colors real quick. It looks like my slope is going to go down 2 over 1, down 2 over 1. So my slope is going to be, actually, I'm going to the left. I'm increasing, not decreasing. So my slope is going to be +2 times x, and then my y-intercept is at 1, so it's +1. So notice this is actually a formula, not just a constant term like we have up here. So with this formula, that is going to happen whenever x is less than 0. Okay? And then if x is greater than 0, I am always going to have +1. All right, so now notice our point here is filled in. So I can land on the y-axis. I need to put an equal sign either here or here. It doesn't matter which spot I put the equal sign at, as long as I do not put it on both of them. Okay, generally I like to put the equal sign wherever I have a formula instead of just a constant term. Okay, that's just a general rule. You don't always have to keep it on the same spot. All right, so in your notes, you have several more examples. I think let's do one more example, and then I'll let you do number 4 on your own. All right, so let's look at number 3. We've got an x of -1. So I have -1 plus 3, and then plus 1. So I end up getting a +3. If x is 0, I get 0 plus 3 plus 0, and I get 3 again. If x is 1, I get 1 plus 3 plus 1 gives me 5. And if x is 2, 2 plus 3 plus 2 gives me 7. So let's graph it. When x is 0, my y is 3, and on the left side it's going to stay 3. And then on the right side, it's going to, let's see, when x is 1, y is 5. When x is 2, y is 7. So again, my slope, I'm going over 1, up 2. So my slope is, again, it's going to be +2. My y-intercept is at, is at 3. So my formula, when x is greater than 0, this is my formula I'm going to use, or my rule. When x is less than 0, my y is always going to equal 3. Okay? I know I went through this fairly quickly. Hopefully you can, if you need to, rewind it, look at it again, see if you can answer problem number 4 on your own, and then move on. All right, so problems 5 and 6. These two, you're going to have 3 different parts to your formulas. Let's do number 5 together, and then I'll let you do number 6 on your own. So let's go with number 5. All right, x is -5. So I have -5 plus 3 gives me -2, which becomes a +2. And then minus -5 minus 3 gives me -8, which becomes a +8, and then I subtract 8. So when I have -5, I end up having -6. When I have -3, I get 0 minus, let's see, -6, right? Yeah. end up with minus 6 again. And then if x is 0, I get 3 minus 3, I get 0. And when x is 3, I get 6 minus 0. So I have a positive 6. And when x is 5, I get 8 minus 2, which gives me a positive 6. All right, so I have this intersection right here at 0, 0. If x is a negative value, my y is going to be negative 6. Let's see, 2, 4, 6. So I'm going to be down here. And it's going to stay at negative 6 the whole time. Then I'm on the left side of the graph. You know what? I don't know for sure if I'm going to have a negative 6 when x is negative 1. Let's try it. So negative 1 plus 3 gives me negative 2, which becomes positive 2. Negative 1 minus 3 gives me negative 4. So I have a positive 2 minus 4, which gives me what? Negative 2, right? So if x is negative 1, then I get negative 2. All right, so I'm not going to say that I'm always going to be at negative 6. I only get to negative 6 when I have negative 3. So negative 3, 2, 4, 6, right here. After that, I'm going to stay at negative 6. And then I'm going to assume that positive 6 is the same kind of thing. 2, 4, 6. I'm going to be up here at positive 6. I'm not going to find all the individual values. I'm just going to say it's giving me a line like this. So now I'm going over 3 and up 6. So I have my slope, my m value is going to be a rise of 6 over a run of 3, which will give me a slope of positive 2. All right. So for my the middle section of my graph, I'm going to have 2x. And my y-intercept is 0, so I don't have to do plus 0. I'll just leave it as 2x. And then the left side of my graph is just going to be at negative 6, and the right side is at positive 6. So when am I going to have that? When x is less than negative 3. And then down here on my right side, when x is greater than positive 3. And now the middle part is when x is between negative 3 and positive 3. My formula is going to be 2x. Okay? All right, see if you can figure out how to solve or how to break down the different parts of your graph for problem number 6. Now, so one of the reasons why we do this is to simplify the formula. If we look at number 5 again, this is a really crazy formula. This one, the y equals 2x, is much easier to work with. And we know that no matter what our x value is, it's going to fall in one of these 3 categories or 3 rules right here. So let's say my number was negative 5 million. Because I know negative 5 million is x would be less than negative 3, I don't have to plug in 5 million in for my x's in this formula. I can just say y is going to equal negative 6. It's a lot easier to do that. Okay? All right, go ahead and work on problem number 6 on your own, and then we'll move on. Okay, one of the things we want to do with piecewise functions is to see which values, or to find out what is the graph going to look like. And so we can plug in different values for x and solve and then graph the problem. So if we take this part, when x is 1, I'm going to use your rule or your branch, I think, is that what they call it? Let me look. Restrictions. Sorry. Told you I'm really not too worried about your terms as long as you know what they do. All right, so the restrictions. It's going to fall between 0 and 5. So we're going to use this top formula here. So 1 times 3 is 3, plus 5 gives us 8. if x is 5, notice we have two parts that include 5 on the restrictions, but only one of those uses the equal sign. Okay, so we're going to use the top formula. So when x is 5, I get 15 plus 5 gives me 20. Okay, and then when x is 10, we're going to use our bottom formula, this one here. So 10 squared is 100 minus 3 gives us 97. And when x is negative 6, notice negative 6 is in neither of these restrictions, so it's going to be undefined. So it would just be undefined. UND stands for undefined. Okay? So there is going to be a section of the graph. If we wanted to graph it, there would be a section. Any negative numbers would not show up on the graph at all. All right, let's look at the next piecewise function. So if x is 0, which one of these three rules or restrictions are we going to use? Let's see, 0 would fall in the middle one. So when x is 0, my y value is going to equal 10. When x is 3, we're going to actually use the bottom one here. So when x is 3, I get 6 minus 6 gives me 0. If x is negative 100, which will be this top one, super easy. It'll just be 8. And if x is positive 100, it'll be in this one. 100 times 2 is 200. Minus 6 gives us 194. All right. Are we pretty good so far? Let's go ahead and look at some real-life problem situations that will create piecewise functions. So taxes. We hate taxes. Most people hate them because there's so many different rules. It ends up being a piecewise function. So you determine, let's read this, you determine your tax credit C based on your annual salary A. If your annual salary is below $24,000, your tax credit is based on 25% of your salary. If the salary is between $24,000 and $50,000, the percent drops to 20%. And if you make $50,000 or more, the credit is 14% of the annual salary. All right, so what are our formulas? If A is the amount that we are paying, then for the first part down from this point on this way, this is the formula you're going to use. We're going to multiply by 25%, so 25% times our A value, our annual salary, and that's when our annual salary is 0, or our annual salary is between 0 and 24,000. Now, why am I using 0? Can you make a negative amount of money? No, you can't. Okay? You can make a 0 amount of money. Notice I'm putting my equal signs there. Then on the middle part of the graph, we're multiplying our annual salary by 20% or 0.20 times A, and that's when we make between $24,000 and $50,000. Is that right? Yeah, $50,000. Okay. And then the bottom part, the next part of our graph, when we're multiplying by 14%, we only do that if A is greater than 50,000. Okay. And I'm going to go ahead and put the equal sign there. I would much rather, if I made exactly 50,000, I'd much rather pay 14% of my taxes than I would 20%. All right, so that's just one real-world problem that's a piecewise function. When you come to class tomorrow, we'll see another one. Whoops. I was looking at a graph and applying it to the word problem. All right, so if you look in this graph, it is not related to the word problem above. I want you to see if you can break down this graph into the 3 parts and solve it. Notice you've got your y-intercept here. Okay, so for this formula, your run is 2 and your rise is 4. So for this section of the graph, your formula is going to be, let's see, 4 over 2 gives you your slope of 2x, and then plus your y-intercept is at +1. Okay, and then this section of the formula, you're going down, I'm picking 3 and over 3, so your slope is -1. So you have negative x. Notice I'm not writing a 1 there. I don't have to. I will tell you, if you kept on going over 3 and up 3, over 3 and up 3, whatever, I will tell you your x-intercept is going, sorry, your y-intercept is going to be at +10. Okay? And then this section of the graph, you're just going to be at 5, y equals 5. Y equals, y equals, y equals, and then the restrictions, this one, let's see, x is 2, so when x is less than or equal to 2, this one, let's see, x is greater than 5, so x is greater than or equal to 5, and then the last one is your middle section. I really should have put this one in the middle, but it's okay, it doesn't matter. So this is when x is between 2 and 5. Okay? Now here are 2 more parts. Graph the given piecewise functions on the grid provided. You should be able to do this on your own. It's getting hot in here. I think this video recording is getting long enough. I'm going to go ahead and stop it here, and we will do a piecewise problem situation tomorrow in class. I want you to graph these on your own. You should be able to do it without a calculator. Plug in some values, set up an x and y table if you need to. Pick some random values. Okay. For this one, I don't know, let's see. You might want to do -1, 0, +1. You probably want to do 3, 5, and 7. Figure out what your values are. And then the bottom one, same kind of thing. Pick some values for x and y and figure out where on the graph they would land. Okay? We will check your answers on these tomorrow in class, and we will have a real-world problem situation that will use piecewise functions. Hope this video was helpful. If you need to go back and rewind and look at it again, you can. You can also find some videos on piecewise functions on YouTube.